Hi, it's Doug. I've got a question for you. Have you ever been on a train? Well, I want you to imagine that you're boarding one. You find a seat, maybe start taking a little nap, and then at some point you wake up and look out the window, see this other train on the track next to you just zipping past. It's going like 70, maybe 80 miles an hour. You think, wow, that train is moving really fast. But then you realize, wait a second, maybe that train is standing still and your train is the one that's actually moving. Whoa. Now, it seems like it should be easy to know when one thing is moving and the other thing standing still. But as this train example shows, there are times when it's not easy. Here's a similar example, this time something that happens every day. Every morning, the sun rises in the east and follows this arc across the sky. Then, in the evening, it sets in the west. It's the sun's daily pattern. Now, is the sun actually moving as it does this? Or are you moving and the sun is standing still? I know. You might think you already know the answer to this question. It's the earth that moves, right? You've probably read in a textbook or heard your teacher say the earth spins or rotates around its axis once each day, making the sun appear to move across the sky. The sun isn't actually moving. But don't just assume something is true just because someone told you so. Really think about this for yourself. Think about what a strange idea that really is. After all, if the earth is moving, wouldn't we be able to feel that? For most of history, we've assumed just the opposite. That the reason it looks like the sun is moving across the sky each day is because, well, maybe the sun actually is moving. That's way easier to assume. It looks like it's moving. How do we know that the earth is moving and not the sun? What do you think? A long time ago, back in ancient times, when people saw the sun moving across the sky, everyone would have told you that's because the sun is actually moving. For example, the ancient Greeks assumed that the sun was going in a circle around the earth once each day, like you see in this diagram. We could call this the sun moving idea. People accepted this idea for thousands of years. But then, around the 1400s and the 1500s, two early scientists by the names of Copernicus and Galileo came along and said that they'd figured out some reasons for thinking that the Earth is what's moving, not the sun. These were some of the first people who came up with this idea that the Earth spins once each day around an imaginary pole, the Earth's axis, and that the sun stays completely still. We could call this the Earth spinning idea, or scientists today call it the Earth's rotation. At the time, many people disagreed with them. After all, it doesn't feel like the Earth is moving. This started a big debate. Both ideas definitely would explain why the sun appears to move across the sky. So, how do we know which of these ideas is true? How did we figure this out? Well, almost no one agreed with these scientists at the time, only a handful of people. And you can kind of understand, right? To those people, it seemed like such a weird idea to look at this and say that the sun isn't moving. People would say to Copernicus and Galileo, look at it. It looks like the sun is moving. And besides, if the earth were moving, wouldn't we notice that here on the ground? But remember the train example. It's not always easy to tell when something's moving, even when you're on it. Copernicus and Galileo had collected a lot of evidence and done a lot of thinking to figure out that the Earth moves. The details, if you're curious, involve part of science called physics, and also some high school level math called trigonometry. But today, since we're living in the 21st century, there's a much easier way to prove that the Earth is what's moving and not the sun. And that's to get off the Earth, to go into space. If we were to get far enough away from the Earth, we should be able to actually see the Earth spinning. And we've done that. This is a robotic spacecraft launched by NASA back in 1995. In fact, they even named it Galileo after the famous scientist. It was sent to study the planet Jupiter, but just a few hours after it launched from Earth, NASA turned its cameras back towards the Earth and had it take this video, which we've shown sped up. You can see the Earth rotating. If you look closely there, you might even notice the continent of Australia go by. Here are a few recent snapshots taken by a NASA spacecraft. This one beyond the orbit of the moon. You can notice the moon moving by in each image. But behind it, you can clearly see that's the Earth spinning. So there you have it, video proof that the Earth spins. By going up into space and looking back at the Earth, we can see direct evidence that the Earth is moving, not the sun. Galileo and Copernicus would be proud. Just like the train example, we may not feel the Earth spinning because it's moving so smoothly. Still, in order for the entire Earth to do one complete spin in a day, that must mean the Earth is moving pretty fast. How fast exactly do you think the Earth is spinning? What do you think?